Welcome back to the morning show, coming up on 6:49 this Wednesday morning. Time for our Wise Guys segment. Our U of I physics professor, Matt Sellon, is in. Thanks for coming in, Matt.
Oh, no problem.
Talking about salt today.
Yeah, well, I was inspired by freezing temperatures and the fact that I almost skid off the road the other day. And in fact, ironically, I was outside. I had a salty kind of a walkway at my house yesterday, and I was outside sprinkling salt on it, and I fell down.
That is it.
Yeah, it was kind of stupid of me. Anyways, so I wanted to explain how salt works to melt ice, because there's a lot of misconceptions, plus there's some cool demos we can do. And so to understand that, first you have to understand what happens when ice melts.
Okay.
So the reason you put ice into a drink or something when you want to cool it down isn't so much that the ice cubes are cold, it's that when ice melts, when it turns from a solid into a liquid, that takes heat. It absorbs a lot of heat in doing so. It's like a little sponge. So just to melt just a little bit of ice requires a lot of heat. And so what happens is if you put ice into just some water, which is what I've done here, and then I put a thermometer in there, you'll see that the temperature is right around 0 degrees, and it's going to stay there until all the ice is melted, because if it were any lower than that, the ice would freeze. Any higher than that, a little more ice just melts, and then it becomes cold again. So these little ice or heat sponges, which we call ice cubes, if they can, they'll absorb heat from its surroundings. But once it's 0 degrees, it can't absorb any more heat, because if it removed any more heat from the surrounding water, that water would just turn into ice, and so you get this equilibrium situation.
Got it.
Okay, so what happens when you actually take ice and you throw it on a roadway or something is the following thing. I'm just going to take a little ice, I'm going to pour it into this cup, some salt, I'm sorry. I'm putting some salt in this cup, so it's kind of nasty looking, and I'm going to mix it up a little bit. And you can see that the temperature is
negative,
starting to drop, and the more salt I put in here, the lower the temperature gets. And so what actually happens is, and actually if you were to measure this very carefully, you'd see that some of the ice was melting right now. And the reason for this is that when you mix water with some salt, the melting point of that water, or the point at which it would freeze when you put it in the freezer, goes down. And it's not really chemistry, it's simply that the salt gets dissolved in the water, and it's sort of surrounds, or it's everywhere within the water molecules, and it makes the water molecules have a harder time just getting together and forming ice. So it lowers the freezing point. And so what now happens is that the ice cubes realize, hey, I can extract more heat from the surroundings, because ice cubes love sucking in heat if they only can, and if they suck heat out of this water, which is now salty, the water doesn't freeze right away, it just gets colder. Okay? So the way you can think about heat and temperature is think about money in the bank. This is the analogy I use with my students a lot. Heat is like money. If you put a bunch of heat into something, the temperature goes up. So your richness, your wealth goes up. It's like if you put money in the bank, your balance goes up. If you take money out of the bank, the balance goes down. The balance is like the temperature, but the money itself is sort of like the heat. So what you're allowing here, when you put salt into this thing, is you're allowing the ice cubes to take heat out of the water. That lowers the temperature of the water, and so it's maybe now you can get it down to -10, -20 even, depending on how much you put in there. Okay, and I realized the other day that the same thing works in martinis, and I just wanted to show you this if we have just a second here, because
we have 1 minute.
Okay, perfect. So the way that you make a martini, and the best martini in the world is made by my bartender friend Jack. And
any secret recipe?
Well, I think it's pretty straightforward. This is basically vodka. Well, it's ethanol and mixed with a little water, which is pretty much what vodka is, except that you wouldn't want to drink this because it doesn't taste as good. But it's probably pretty close. Here's just some ice cubes in here. I'm going to just put this in here, and this is room temperature vodka. And this is why James Bond says shaken, not stirred, by the way. So what I've done is I put some ice cubes in there, which are at 0 degrees. I put some vodka in there, which is at warmer than 0. It's sort of room temperature. Now I just shake this for a while. So what's happening now is that since that vodka itself is going to mix with the water as it comes off the ice, as the ice melts, the vodka will act like the salt. It'll make the freezing temperature of the liquid much lower. That's why you can stick a bottle of vodka in the refrigerator or in the freezer and it doesn't freeze. And this thing gets, see how it's getting frosty already? Okay. So let's take this thing. I want you to hold that in there for me. Okay, so without touching the sides. And I'm just going to pour this in here, and we'll see how cold it is. -10.
Wow.
Okay. And so if you just move that, so that's why when you get your shaken, not stirred vodka martini from Jack, you notice that it tastes really, really, really cold. And it's just because even though you start with ingredients which are all much warmer than the temperature we just measured, after all that shaking, the freezing point is depressed and the heat is absorbed from the surroundings, and there you go. So when we come back, I'm actually going to make some ice cream using this thing.
Oh, cool.
And I have a little sheet of ice outside, and what I'm going to do is right in the break, I'm going to sprinkle some salt on it, and also some of this ice melt stuff, so we can compare which one works better, because I've never done that before.
Oh, good. All right, Matt. Well, thank you very much.
Okay.
Very interesting. All right, you want to